All right, so with this question, it says find the indicated critical value, and we have this z with this little subscript 0.11. Let me give you first the official definition straight out of the book here. So you can see that for some standard normal distribution, a critical value is a z-score separating unlikely values from those that are likely to occur. And the notation is this expression z alpha denotes the z-score with an area of alpha to its right. All right, so they just tell you then that little symbol is the Greek letter alpha. So what we're saying here is we have, if we draw a picture of this, and we have a normal curve, this expression z alpha 11 says over here to the right, on the right end of the curve, this area right here is equal to 0.11. All right. And that's that area right there. So they want to know, what is this z-score? That's all this question is getting at, is trying to understand that question. So there's several ways to go about this. The graphing calculator is maybe the fastest way if you have that. Let me show you that. So with the graphing calculator, what we do is we do second distribution, and then we go down to inverse norm. All right, that's the option we're going to choose, and that basically does the inverse of the normal process there, the normal distribution, and we just type in 0.11. Now what's going to happen here is it's going to give us a negative number. And the reason it gives us a negative number is because the calculator can only do, this calculator only does area to the left, starting from the left. So in other words, the calculator thinks we're talking about this right here where the area on the left-hand side is 0.1. The calculator can only do from the left going this way. And so what we realize here, one, is that the normal curve is symmetric. So we got negative 1.23. And what that should tell us then is that we realize that the other score over here should be positive 1.23. Now let me just go ahead and show you how we can do that just so we're clear. If this area is 0.11 and this area is 0.11, then how much does this area in the middle have to be? You can do the math. The area needs to be 1. Right, so we do 1 minus 0.11 minus 0.11, we get 0.78. That's the area here in the middle. So if you tell the calculator, remember it goes area from the left, if you take 0.11 plus 78, right, you're going to get 0.89 is the total area under here. Let me get a different pen color here. So this whole area here, the whole green area, is 0.89. Another way to think about that is the idea of a complement. It's 1 minus 0.11. So let me get the graphing calculator back out and I'll show you how we get that to happen, and a cool thing's going to happen. So I'm going to do second inverse norm, and now I'm going to do 0.89, my green area. And what that's going to give us is the exact same z-score, but positive. It'll give us that positive number, which lets us know that this is 1.23. All right, just showing you that the whole thing is symmetric. If the area to the right is 0.11 or the area to the left is 0.11, we get the same thing. One's positive and one's negative. So generally I just tell students, after you do this enough, put in inverse norm 0.11 and realize the answer is not negative, it's the positive version. That's really all you need to know. And now just to show you on the tables how this is done in case you don't have the calculator. With the tables, we take the same approach. Either look up the area 0.11, and so on the tables, you have to go looking around. Where's 0.11? Here's 0.1112, and here's 0.1093. So this one's 7 away from 0.11, and this one's 12 away from 0.11. So we actually use this one, and that's also why we get negative 1.23. So again, you get 1.23 that way as well. All right, and the same is going to hold true if you looked up the area of 0.89 on the table, you'll get the positive version 1.23. So anyway, that just explains critical value, what all that stuff means. But it's talking about error. Alpha is always talking about error, and it's our chance for ending up in this space over here without some cause.